Mr. Robinson, I accidentally pinned your video, so now the do now's gone. How do I unpin it?
I don't know. The screen share and the
Yeah, I just switched to screen share. I did it.
Okay, we got 11 people in, still waiting on 5 more. We'll get going in about 3 minutes. In the meantime, feel free to start the warm-up. So triangle ABC is an isosceles triangle such that AB is similar to AC. And so the measurement of length BC is 48 units. If the length of DE to DF is 5 to 7, that ratio, please find the length of DC. Now, we have an upper limit that our length has to satisfy. What is that upper limit? What does DC have to be shorter than? Anybody?
7.
Nope.
Oh, wait. Oh, 48.
It better be less than 48.
Yeah, 48.
Yeah, BC is 48 in total, and if we're looking for DC, which is a subsegment of BC, the answer you get better be less than 48. Try and figure this one out for yourself. It's not that hard, but just so y'all know where this is from, this is originally an SAT question, and then, you know, it would have 4 multiple choice answers that are all shorter than 48.
Mr. Robinson?
Yep.
Have you graded the test yet or no? Like the multiple choice part?
Nope.
Or I mean the other part.
Nope. If they were graded, the scores would be up.
Okay.
You will get those back as soon as I both find time to grade them, because yesterday afternoon I had a class to watch online also and some homework to do. And also after I figure out a good way to give you guys back your feedback, because that I'm not sure about, because, you know, I can't physically hand back to y'all a graded test. Like, I don't just want to give grades and then put the grades up without y'all knowing which ones you got right and wrong. So after I figure out a good way to do that, I'll get your quizzes back to you. Okay, time's 11:40, so let us go ahead and get started. And today notes will probably be a little bit short, so if we finish up early and I get the homework sent out there, we might just call it early, yeah?
Yeah.
Okay, so item number 1, does anybody out there have an answer?
I got 28.
So you got 28, which would mean that the other length, BD, would have to be 20, right?
Yeah.
And so you're saying that 20 and 28 would give us back the correct ratio of 5 to 7?
I think so.
You are correct. Very good. So the answer to this question is DC is equal to 28. But let's go ahead and prove out why from principle. So what's up with this first piece of information? Why do we care that triangle ABC is isosceles such that side length AB is congruent to side length AC? What is this line being the same length as this line? What does that actually give us?
It shows that those two lengths are going to be equal.
Sure, I mean, that's just a restatement of what it says, but what is that? What useful information does that give us? Anybody?
That two of the angles are the same on the bottom.
Good. So if a triangle is actually isosceles, not only does it have 2 congruent lengths, it also has 2 congruent angles. So that's what tells us that angle B must be congruent to angle C. How is that useful to us?
Then we can say that that angle D, like the left side and the right side of that D point, or those angles?
Because then we can logically say that the two smaller triangles are similar because
By
we
which
know
similarity?
angle.
That's what's up. So by angle similarity, since these both have one 90-degree angle, and we know that we have this other congruent angle, this allows me to write a similarity statement. And here's the way in which I'm going to go around and I'm going to write that similarity statement. I am going to start with the 90-degree angle, then I'm going to go to the known angle, and then I'm going to finish on the unknown angle. So this is to say that triangle EBD is similar to what other triangle?
FDD.
FCD.
Oh,
It would have to be FCD because, again, if it's 90 and then known angle and then unknown angle, over here it also has to be 90, known angle, and then unknown angle. And so what we're looking for is DC, right, which is the last two letters over here on this part of the similarity statement. So that has to line up with BD, the first two letters on my similarity statement. So let's go ahead and start off by writing a ratio with the given information, 5 to 7. So this is telling me that the length from the short triangle, when divided by the length of the big triangle, would have to give me a ratio of 5 to 7. So what ratio will this be on the right-hand side?
I did it a different way.
BD over DC.
So if short divided by big, is it going to be 5 divided by 7? Then that means the other lengths that we are playing with, BD divided by DC, would have to give us the same ratio. So that's BD divided by DC.
I did it a different way that's like solvable.
Okay. Are there any questions on this setup so far?
No.
Okay. So I'm going to take this and I'm going to cross multiply it. So this gives me 5 times DC is equal to 7 times BD. However, this is one equation with two variables, and that's not okay. Who can explain why not? Why is it not okay to have one equation with two variables?
Because then you logically can't solve for either variable.
You can't combine them.
Correct. And there's a name for that that y'all should know. The name of that is called the Fundamental Theorem of Algebra. The Fundamental Theorem of Algebra says that if the number of variables equals the number of equations, then a solution must exist. Of course, there's a few extra conditions for it on top of that. Also, don't unmute yourself like permanently. If you want to talk, just press spacebar to talk.
Yes.
Nonetheless, the Fundamental Theorem of Algebra says that the number of variables has to be equal to the number of equations. And if we find ourselves right here with two variables, DC and BD, it either means that one of these we need a number for, or we're going to need a second equation. What is the second equation that we can generate?
A 7/12?
No.
Can you do like 5DC plus 7BD equals 48?
It's definitely not multiples of those things that add up to 48, but that is the unused information. So here's what we know. The measurement of length BC is 48. So what's the other equation that I can write? This whole length down here, from here to here, that's 48. So what other equation can I write that relates these two?
Is it 5DC plus 7BG equals 48?
Again, I had that offered as an answer. That's not correct because it's not multiples of those things that add up to 48. It's way more straightforward than that.
5 plus 7 equals, no.
BC plus BD equals 48?
Yes. If the total length from here to here, if BC is 48, and these are the two other variables I'm playing with, length BD and length DC, then that means that BD plus DC have to add up to 48. So BD plus DC equal 48, And now notice I have conformed to the fundamental theorem of algebra. I have two equations with two variables, and as such, I can go ahead and solve. So how should I do that? How would y'all like me to do that? Which variable do you want me to solve for first?
BD, maybe.
Okay, so we'll take this bottom equation and we'll solve it for BD. And how do I get BD alone?
You cancel it, I think.
Minus DC.
I'm going to
Subtract
subtract DC over to the other
Subtract
side.
DC
On
from both sides.
So BD is going to be equal to 48 minus DC. And now that I have a redefinition of BD, I can take this and I can substitute it into my other equation right here where we see BD. So this is to say that I have 5 times the quantity DC. This has to be equal to 7 multiplied by BD, but this equation right here that we figured out lets us define BD. So it's going to be 7 times 48 minus DC. And now notice I have one equation, and how many different variables are here?
Only one.
Only one. So now I'm going to go ahead and solve for DC. So 5 DC is equal to, what's 7 times 48?
200. No. 336. Yeah.
Minus 7 times DC. And then how do I get DC alone?
Divide by
You
DC.
You subtract.
You divide.
No.
You
I'm going to
subtract.
add 7 DC to both sides of this equation.
I'll just subtract.
And so on the right-hand side, DC cancels with DC, and on the left-hand side, I get that, what's 5 plus 7?
12.
12 DC is equal to 336. And so now I can divide both sides by
12.
12.
And you get 28.
And this gives us that length DC is equal to 28, which works out very nicely because it fits with all of our initial conditions. So if DC is 28, that means BD has to be 20. That has to be true in order for these two to add up to 48, which was one of our initial conditions. And here's the other reason why we know that this works. The ratio of 20 to 28, what ratio does that give us back?
5 to 7.
5 to 7. If you take both of these and divide them by 4, it gives you back a ratio of lengths of the triangle of 5 to 7. So this gives us both the correct total and the correct ratio. Are there any questions on this item or warm-up for today?
No.
Can you do it in a way where you just do 7 from the beginning, just do 7 over 12 equals x over 48?
No, you can't do that because 48 is not a length of one of our similar triangles.
No, but
And
48
also 12 is not either.
48 is a length that belongs to the big isosceles triangle at the start. 48 represents this length right here. And the big triangle is not similar to either of these little triangles.
then how did it give the correct answer?
Then it's a mathematical coincidence. It doesn't work for any special reason.
Oh.
Are there any other questions on this warm-up?
No.
Okay. So today we're going to get into notes, and we only have 2 sections of notes before the end of the chapter. So we'll have notes today. We'll have notes again on Thursday. And then next week, at the top of the week, we'll do a full chapter review. And the last thing that we'll be doing before we head out to spring break is doing the chapter test for chapter 7, so that when we come back, we can go over it and then start fresh on the most important chapter of the entire year easily, which is called trigonometry. Today's notes are really, really straightforward. And so I think we're going to finish early. If that happens, I'll post the homework and you can get started on it, or we could just call it and I'll head to lunch a little bit early. But today we'll be talking about section 7.5. Today we'll be talking about parts of similar triangles. Oh, and by the way, did y'all see the information I posted about the virus the other day on Classroom?
Yeah, I looked at the chart. I looked at those charts.
Yeah, so the first one is a GIF, the second two are videos, and then the last two are different articles. Do check that stuff out. Like, you should be responsible for educating yourself on the topic. The only one of those that I'm going to talk about in particular is the open source ventilator, because y'all had a quiz yesterday, so I wasn't able to talk about it to the group. But have any of you heard about open source ventilator?
Yes, I believe so.
What is that?
I have no idea. I've heard of it though.
Oh, hold on, my Zoom just crashed.
Damn.
Yeah, my Zoom just crashed. Give me 1 second. I might have to stop the meeting and restart it. Uh-oh. Wait, can y'all hear me?
Yeah.
I can see your face.
Yeah.
You can still see
Yeah,
me?
we can hear you. Yeah.
I can hear. Yeah.
And see you.
It just the stop the
The
sharing.
camera, like,
Sharing
blacked
stuff.
out.
Yeah, your screen sharing was
You
black.
stop screen sharing.
Yeah, I stopped screen sharing because I need to restart Chrome. It crashed. Okay, so here's what I'm going to share with y'all. Okay, cool. Chrome recovered, Zoom recovered. Zoom, screen share. Oh my God, shut up, Google. Oh my God, my phone. It heard me say the word Google out loud and it activated the like voice commands. Hey, anyway, do y'all see that screen share?
Yeah.
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 Hey, so here's the deal, and here's why I'm going to talk about it. One of the biggest dangers of the virus is the fact that if the infection spreads fast enough and enough people are sick simultaneously, then we will run out of hospital space to accommodate all of those sick people, which means more or less that, you know, if you get sick and you need an ICU, you need access to a ventilator, and without it you'll die, then that's what's going to happen to those people who can't get access to that type of medical treatment. They will die, you know, with no intervention. And we're already starting to run out of certain medical supplies, but one of the rarest and most expensive supplies that everybody getting treatment for the virus will need is called a ventilator. It's just a machine that's capable of breathing for you. So the virus messes up your lungs pretty bad, and to keep people alive as their lungs are being damaged by the virus, we use a mechanical breather that breathes for them, except ventilators are extremely expensive, difficult to put into mass production, et cetera, et cetera. So there's a product called Open Source Ventilator, which was completed in 1 week by a team of approximately 300 engineers working remotely, just a bunch of people contributing designs and code to GitHub, which, if you don't know, GitHub is the standard website for how teams work together to produce code. And so in 1 week, that team of 300 engineers was able to make both the 3D printer files that you need to print out with your 3D printer, instructions on how to assemble it, instructions on how to assemble the circuit board that controls it, and the code that you need to put on the circuit board itself. And this is like a picture of the finished design. And these things can be quickly and cheaply assembled. The goal is to try and meet the needs of people needing ventilators before they need them as the pandemic proceeds. And this type of like desperate emergency response to try and meet the needs of people in the coming weeks goes hand in hand with a bunch of other extreme efforts, like in Washington, how they're converting the Seattle Sounders soccer stadium into a giant hospital itself. Like they're just actively using construction crews to convert the stadium itself into hospital beds, because that's what we're going to need in about a week or two. And the reason why I bring this up is that, you know how like y'all have your classes that you have to attend and learn on Zoom? I do too, because I'm still in grad school and I'm still in 2 classes. And so I need those 2 classes to continue on Zoom. But one of my classes is taught by a dude who works up at JPL, and he just straight up pieced out on teaching the class. And he's like, hey, yeah, I can't teach the class anymore. We're not going to do that. Instead, my TA is going to teach the class. And the reason why that dude has to disappear is that JPL is switching over a lot of their on-site manufacturing capacity to making these ventilators.
Wait, Mr. Robinson,
Mm-hmm.
would you think this is gonna like cause something worse than the Great Depression?
All of that is speculation, but it's definitely going to be, it definitely already has been bad for the economy. And yeah, it's definitely bad for the economy.
Are these like next few weeks like the peak weeks of the virus?
It completely depends on human behavior, and considering people, especially in this country, tend to be particularly poorly behaved in these times. I doubt it. Like, ideally, if everybody went home and actually stayed at home and listened to those instructions, we would have a very long and low pandemic. Like, the number of people infected at any given time would be very small, and it'll spread out across various communities slowly. And ideally, the goal would be to make it so that there's enough hospital beds to treat everybody who gets infected. But what I expect to be more likely is that since people are poorly behaved and can't stay inside physically, like it got to the point where the city shut down the public parks because dummies are meeting up at public parks to hang out with their friends. Instead of there being one outbreak and then having stuff calm down, there will probably be an outbreak, stuff will calm down, people will get back to living like normal. And then because everybody goes back to work immediately, it'll cause another outbreak and we will get to go through this cycle again. But like I said, it just depends on random chance and human behavior, and I tend not to bet on human behavior.
Aren't officers like giving citations to people they see who aren't like family, like to get her out?
Yes, and they should, because you should not be meeting up with your friends. People shouldn't be doing that. It was driving me crazy the other day that I like was out on a run, and when I went past the park, there were people who like met up there to have a picnic. I understand why they had to shut the parks down.
Yeah.
How
Wait,
long
Mr.
do you
Robinson.
think this is gonna last?
Longer than any of you think or are prepared for.
Mr. Robinson, wait, is it true China has no more cases?
No, that's nonsense. Nowhere will have no more cases until the virus is eradicated. Nobody will be able to make that statement until there's a vaccine, because no matter what, if there is one case on the ground, there is a chance that that person infects somebody else. It's definitely not zero. No.
Was it true there's a vaccine but it hasn't been tested yet?
There are vaccines in, no, you need to be careful with your language. There are vaccines in production that are currently being tested.
Like anti-malaria or something?
What?
Anti-malaria, aren't they using that?
No, and they shouldn't be. That doesn't even make sense, because malaria is not even a comparable disease.
Mr. Robinson, when do you think these vaccines are going to be available to the public?
And I don't know why anybody, hold on, first things first, I don't know why anybody would be talking about anti-malarial medication, because like I just mentioned, those two diseases aren't in the same like family at all. This outbreak is a virus. Malaria is not a virus, it's a parasite. So I don't understand the way in which the same medications could possibly work for both. And number two, for there to be a vaccine and for it to be available, like optimistically, we're probably 6, 7, 8 months away from that. Because even once, like, let's say that, all the research goes good and we have a vaccine that works and is good and effective and safe, to get that homie into mass production and get it widely distributed, that alone will take 4 or 5 months to just like make that much of the substance and then get it packaged and sent out around the world. when that happens, then it'll be made available first to healthcare professionals so that they can protect themselves. And then it will go to the general public secondarily. So even after the research is done, it's going to take like half a year to get it out into the public. But even before that, you have to find the vaccine first, right? And you can't guess how long that'll take. Like, there are people working on it, and if the first round of testing is successful, great, but you literally can't know whether or not it's effective until after that testing is done. And based on the outcome, we might have to start over from zero and figure out a new approach to the vaccine. Or if that first test works, great, then we might all be vaccinated before the end of the year.
Ooh.
Okay. Any other
Wait, quick
questions
question.
on that stuff? What?
Is it true if you get corona once, you're immune for the rest of your life?
In general, that's how immunity is supposed to work. Once you have a disease, you shouldn't get that disease again, is the like high school biology textbook description. But of course, if it's being taught to you out of a high school textbook, it's an oversimplification of the reality of the matter. So just for example, once you have chickenpox, you shouldn't get chickenpox again. I got chickenpox twice because you can easily get a disease twice just by being slightly unlucky. Not to mention, chickenpox is a disease that once you have it, it lives in your nervous system forever, which is why later on in life you can get a flare-up of the chickenpox virus called shingles. So again, even once the COVID-19 has burned its way through the human population, what the long-term effects of it are, or how it mutates and becomes secondarily infectious, or any of that stuff is all up in the air. Still, the best rationale, the best approach to take would be to say, hey, we would rather just eradicate this. We would rather make it so that the virus dies out in the public population so that we don't have to worry about what its long-term effects are. Okay. Today we're talking about 7.5 parts of similar triangles. And like I said, once we actually get rolling with these notes, they're pretty short, they're pretty straightforward. There's not actually any new math here. There's just one extra layer of logic that will make it so that we can solve some problems that we wouldn't have had the initiative to solve before. So here's the whole thrust of the section. When it comes to triangles, if we know that two triangles are similar, so given two similar triangles, we can know that corresponding special segments are related by the same proportionality which is just a fancy way of saying the same scale factor as the other sides of the triangle. And just a quick recap on what our special segments are. Our special segments can include the following. Our special segments include altitudes, angle bisectors, and medians. Let's do a quick recap just because it's been a little bit since we used these. What's an altitude?
A 90-degree angle, like perpendicular.
Good, I got one side of the triangle. Our altitude is going to be 90 degrees to that side of the triangle. And then what is it going to touch on the opposite side of the triangle?
It's going to touch the vertex.
It's going to touch the vertex on the opposite side. What about an angle bisector? This one's pretty, self-explanatory.
It just has to bisect
It
the angle.
bisects
That's
the
all.
angles.
Yep, it
That's all.
bisects any angle, and then it goes off, and then it touches the opposite side wherever it was destined to. And then what about a median?
It goes
Um,
from one vertex to the midpoint of another side.
Yeah.
Very good. It's going to stretch from one vertex to the midpoint on the opposite side of the triangle. And
What about centroid?
Oh, that's a good question. So centroid. Oh, no. So the centroid is where three of these segments meet. So the centroid is where centroid is not a special segment, it's a point. And oh boy, I forget about this all the time. The centroid is where all the medians would meet in the middle of a triangle.
Yeah.
Yeah, that's a good question. We're not talking about those points in this section. We're only talking about the special segments that form them.
Okay.
Mr. Robinson,
Yes.
something happened, so can I quickly leave and join again?
Yep.
Thank you.
Yeah, and you don't have to ask if you have to hop off to go do something. Just make sure you come back.
No, it's just because I can't see it, so like I have to redo it.
Yeah, that's fine. Just figure it out. And here's the rationale in terms of why. The reason why is that these special segments will divide pairs of similar triangles into two pairs of two similar triangles So let's just go ahead and say, to illustrate this notion, that I have two similar triangles, a big one and a little one, and they're related by a scale factor, which is, just for the sake of simplicity, a to b. We don't really care about what this number is, right? All that we know is that they are similar. That's a fact. And so I'm going to go ahead and say that this one right here is triangle A, B, C. This one over here is triangle D, E, F. And what I know is that triangle A, B, C is similar to triangle D, E, F by a scale factor of A to B. And so if these two are similar, what does that tell us?
Their angles are
That's the big thing that it tells us. I know that if I took this and divided it by that, I would get A over B. If I took this and divided it by that, I would get A over B. If I took this and divided it by that, I would get A over B. But the other information that it tells us that's really important is what angles themselves are similar. So knowing that these two are similar tells us that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. So if I go back into this triangle and then I add, for example, an altitude, here's what that's going to tell me. I'm going to start at point B and I'm going to drop down an altitude so that this guy makes a 90-degree angle down here. I'm going to add an extra letter to represent this point where the altitude touches. That'll be point X. And then over here on the right, I'm going to do the same thing. I'm going to drop down an altitude, 90 degrees, and I'm going to say that it makes a point Y. Notice here on the left, this triangle has angle A, this has angle D, those are the same angle. It also has a 90-degree angle here, it also has a 90-degree angle here. So what does that tell me about this right triangle and this right triangle?
similar.
They are similar.
They're similar.
They are similar, yeah, by a similarity. And the same is going to be true for the case on the right. Angle C is congruent to angle F. This is a 90-degree angle, and this is a 90-degree angle. And again, I can use that information to establish a similarity for the triangles on the right. So the reason why this works out is that any given triangle, when cut with a special segment, will then produce two new triangles, which themselves are also similar. I'm going to write down those similarity statements down below, and while I write those, y'all can ask questions. What was the question out there?
Is altitude basically just height?
That's fair, yeah. If you were talking about like, hey, calculate the area of this triangle, if you were to use 1/2 base times height, you could say 1/2 base times height, yeah.
Oh, okay.
So this is to
I
say
have a
that,
question.
hold on, based on the way that this altitude is tossed in here, triangle BAX would have to be similar to triangle EDY. And for the same thing on the right, triangle BCX would have to be similar to triangle EFY. And both of these similarities will keep the same ratio that they did before. Both of these similarities will go as A to B. Okay, what was the question?
EYF.
Sorry?
Would angle BAX be similar to triangle EYF?
Yes, so BCX in that order would be similar to triangle EFY in that order, and that's written down here, yeah.
Mr. Ross, I had 2 questions.
Mhm.
What's that ratio A to B? What's
That's
that
our
for?
scale factor.
So what's it?
It doesn't matter. This is just for the sake of notation. If you were actually solving for this, you would need to know numbers. But like I said, this is just the scale factor.
And also, this would also work if we were doing angle bisectors and medians.
Yes, the exact same thing works. And in the homework, you'll take a look at that for the exact same reasons, because angle bisectors will give us information about angles, and medians is a little bit harder. That's not going to give us information about angles, but it will give us information about lengths. These will also produce similar triangles, yeah. The logic is exactly the same, though the diagrams will be slightly different.
Is it only me that hears like Donald's voice glitchy?
No.
The
Yeah,
way
it's
that you hear
only-
people depends on your relative internet connection, so sometimes when y'all ask me questions, it's a little bit laggy and slowed down, but I wouldn't think too much about it.
Okay.
And so let's go ahead and have a quick example of this type, and then know that tomorrow when we come in, we'll have a warm-up question of this variety. I'll choose one of the different segments so that we could get practice drawing those as well. And as soon as lecture's over, I'll post the homework. The homework will go up as 2 PDFs, so of course I don't want everybody wasting all of their printer paper and ink at home. For the homework moving forward, feel free to answer it on a separate piece of paper and just upload that separate piece of paper. So here's what I got for you. For example, triangle MNO is similar to triangle PQR, and here's our little image. Okay, so then this length here, oops, sorry, let me pull it. Yeah, that's the one. Let's go ahead and say that this one here is 29. And then this one over here is 12. This altitude right here is going to be 20. And what I would like you to solve for is solve for this length over here on the right. I need this x. So yeah, please solve for x, which is the distance from point M to the base of whatever that altitude is. Take about 60 seconds. Talk it over maybe with your classmates since y'all have been stuck at home anyway.
Mr. Robinson, are you gonna have to use Pythagorean Theorem?
You are, yeah. And how come you know that you'll have to use Pythagorean Theorem?
Because there's a right angle which shows a right triangle.
That's part of it, yeah, and that's why I bring this one up, because sometimes in the questions that involve altitudes, you won't have the side lengths that you need to use right off the bat. But yeah, whenever you see a right triangle, keep in mind that we have the Pythagorean theorem in our toolkit. There's another more straightforward reason why we need to use the Pythagorean theorem. It's due to the simple fact that this length here would correspond to this length here for the right-hand triangle, this guy. And so for us to set up some sort of ratio, we need to know what that length is, yeah? Are y'all ready to go ahead and get started on this question?
Yes.
Okay, so what we're gonna do is we're gonna solve for this unknown value first, simply because this length corresponds to this length in our short triangle. So I can say that our unknown length squared plus 20 squared is gonna be equal to 29 squared. And why would I set it up that way? Why do I know that 29 squared goes on the right?
Hypotenuse.
It's the hypotenuse.
Yeah.
Yeah, exactly. It's the hypotenuse. The long side goes over there on its own, which is to say our unknown length squared plus 400 is going to be equal to 841. Subtract 400 from both sides. Our unknown length squared is going to be equal to 441. And then how do I solve for that unknown length?
Square root.
Hit it with a square root. And so our unknown length is equal to, what's the square root of 441?
21.
Yeah, probably, yeah.
21 exactly. So notice this thing here on the right, this is a Pythagorean triple. So by knowing that this length is 29 and that our altitude is 20, that can tell us that this piece over here, this must be 21. And so I can go ahead and set up a proportionality ratio now. So since I know that these triangles are proportional to each other overall, I know that any sublength will also fulfill that exact same ratio. And so what is a ratio that I could set up that'll let us solve for x?
21 over 29 is equal to x over 12.
I like that. So I got 21 over 29, which is to say on our big triangle, this sublength divided by the hypotenuse. So I'm going to say sublength divided by hypotenuse must be equal to sublength divided by hypotenuse on the left as well. And now this is nice. I'm gonna have to cross multiply that. To get x alone, I just have to multiply both sides by 12. By 12. On the right, 12 and 12 cancel. And so x must be equal to 12 times 21 over 29. 12 times 21 is 252.
252.
And I believe that 29 is prime.
You get like 8 points. 8.6.
Yeah, it is.
No, you don't. You get 252 over 29.
Oh, okay.
Yeah, that's what I left it at.
Yeah, and that's simply because 29 is, well, I don't want to misspeak. Let me make sure 29 is prime and that I'm not being dumb.
29 is prime.
Yeah, 29 is prime. Yeah, I'm not crazy. Yeah, and
Only
so
by
Robinson,
1 and 29.
You could simplify it to 42 over.
you cannot,
Never mind.
because 29 is prime, which means 29 only has two factors, one in itself,
One in
and whenever
itself.
you have a prime in a fraction, that fraction is necessarily unsimplifiable. Does that make sense?
Yeah.
Yes.
Okay. Are there any questions on this little example question here?
Nope.
So, like I said, this homework is pretty straightforward. It's the same as the stuff that we've been doing this chapter so far. We're just setting up clever fractions and cross-multiplying in order to get lengths. The only difference is that we have to acknowledge that special segments, when drawn into similar triangles, will produce triangles which themselves are also similar. So since I know that these two guys are similar to each other, we started off knowing that this angle is congruent to this angle is congruent to this angle, and this angle is congruent to this angle. So even when I toss in that additional altitude, we still get a similarity. We still get a similarity, and that's how I know it's appropriate to set up a proportion and cross multiply in order to get an unknown value. I'll post the homework right now, and then we can all head out to lunch about 10 minutes early. Don't tell anyone. And I will see all of y'all tomorrow at the same time, same channel. We'll start off with a warm-up, and then we'll have the rest of the period to work on the homework. And at the end of that period, I'll just read out the answers to the homework, just because I can't post them since all that stuff's copyrighted. And I guess that's just how we'll do the solutions from now on. So if you miss out on class, you don't get the homework solutions.
All right. Bye, Mr. Robinson.
Bye, Mr. Robinson.
Y'all have a nice day. I'll see you tomorrow. Go
You too.
exercise. Yeah, use a workout
Thank
app.
you.
Go do some yoga. Peace, y'all.
I have a question.
Yep.
So how do you access the videos for the AP college board? They said they're gonna be putting videos online. How do you access it?
I will post that link right now before I end the stream.
Okay.
You're talking about the review videos?
Yeah, they said they're gonna be posting supplemental courses.
Yeah. So since they are cutting all of that stuff short, and you're looking specifically for human geography, right?
Yeah. I saw they posted a schedule or something, but that's all I saw.
Yeah, they posted a schedule, and that schedule is also where the links are. So here's a posting to the AP Human Geography Review lecture. It goes live in 25 hours, so I just posted it on Google Classroom for you. That will go up, yeah, it goes live in 25 hours, so you can look at it then. But for
watch it?
No. Once it goes live, it'll also be just backed up there, so that link will work even if you're late to view it. But these lessons start going up on Wednesday.
Okay. Thank you.
Okay. Yeah, you're welcome. Have a nice day.